Wait and notify methods can be applied to any object, but that object must be under the lock of the calling thread. Let's understand this statement. Here, look at the two Java files. Here there are some changes in these two codes. Here in this case, the thread main, before calling the method wait, by using the reference variable s, got a lock on an object whose reference is stored on the reference variable s. After that, it calls the join method by using the reference variable t1. That's why in this case, the thread main is waiting for a notification from the new thread. And when the thread main goes to the waiting state, before to that, it releases the lock on an object whose reference is stored on the reference variable s. So the lock on that object will be released with this statement. So when the thread main releases the lock on an object whose reference is stored into the reference variable s, the new thread gets a lock on the same object. After that, the new thread calls the method at this much time. When the for loop gets finished, the new thread calls the notify method by using the reference variable s to notify the method main that it has finished its work. When the new thread calls the notify method, it releases the lock on an object whose reference is stored into the reference variable s, and the same lock again acquired by the main thread. After that, the main thread calls the display method. So this is how the main thread can wait for the new thread to complete its work without sleeping. Here the main thread is waiting for a notification for the new thread, and the new thread is giving the notification by using the notify method. Before calling the join method, the main thread has locked the shared object, and while calling the join method, the main thread has released the lock. The same lock is acquired by the new thread, and after notification, the new thread also releases the lock, and the same lock again acquired by the main thread, and finally the main thread calls the display method. So the thread main is waiting for an update on object referenced by s. New thread is responsible for updating the object. After updating it, new thread notifies the main thread. Then after, main thread resumes its work. The statement s.wait makes the main thread to wait in the wait state until new thread gives a notification. Thread main first releases the lock on the current object, not all object. Means it will release the lock on that object on which it is calling the join method. So the thread main first releases the lock on the current object immediately and then goes to waiting state. The wait state is non-runnable state. Means the thread main will not disturb CPU until it gets notification. Statement s.notify calls the new thread to give notification to main thread. As we have seen that any thread can call wait or notify methods on any object. Here we have called the wait and notify methods on an object of type shared. These two methods can be called on any Java object. That's why these two methods along with notifyall are present in object.class. We know that all the classes in Java gets inherited from another class called object. The name of the class is object, and all the classes in Java gets inherited from object.class. That's why these two common methods, which are actually common for all the classes in Java, have been put into object.class, and another method notifyall is also present in object.class. The object on which a thread is using these methods should be under lock of the caller thread, as we have already seen. Otherwise, we will get illegal monitor state exception. Statement s.notify also releases the lock, but may not immediately. Threads main and new are releasing locks because they want each other to work on the same object. So while calling the method join, the thread main will release the lock on an object whose reference is stored into the reference variable s. And while calling the method notify, the new thread will release the lock on an object whose reference is stored into the reference variable s. They are releasing the locks so that other can use it. They are releasing the locks for each other. After getting notified, main thread has to acquire the lock again. Then only it can continue further, as we have seen in the earlier slide. Because the thread main has to start from this point, that's why to start from this point, the thread main again need the lock because the thread main is still inside the synchronized block. If new thread starts execution before the thread main and execute notify method before the thread main execute the wait method. Means what I'm talking here, the thread main has not called the wait method, but the thread new has called the notify method. This can happen. What will happen if this occurs? Who will take this notification? Will it go in the garbage? And what will happen when the thread main calls the method wait and the thread new for which the thread main is waiting is not going to notify it? Then in this case, the thread main will keep on waiting forever. But if this does not happen, then the thread main has to wait until notification. What's happening here? After calling the method start, the thread main goes for a sleep for 100 milliseconds. In between, the new thread got a lock, execute the for loop completely and calls the notify method. But here no one is present to get notified. After 100 milliseconds, the thread main again starts execution. It gets a lock and calls the method wait. But now, for whom the thread main is waiting, is not going to notify him. So this is what is happening in this case. The thread main is slept for some time and in between, the new thread notified it. This notification missed by the thread main and it keep on waiting forever for the new thread. Output is hanged screen. Let me try this code practically. Open mythread.java and this is the same code as we have seen. Open create thread.java and this is the same code as we have seen. Open share.java and again this is the same code as we have seen. Now compile these three codes, Java C, create thread.java, mythread.java, share.java. It compiles fine. Now run it. Java create thread. We have a hanged screen on the output because the thread main is waiting for the thread new, but the thread new is not going to notify the thread main because the thread new has already notified the thread main when the thread main was not ready to accept this notification. Therefore, you have different wait methods. The wait method without any argument. We already have seen this wait method in the previous examples. This wait method without any argument, wait until you get notification. We have another wait method which accepts a long as its argument. So this wait method will wait at most ms milliseconds and continue if notification does not come within this much milliseconds. The another wait method accepts two arguments. One is of type long and other one is of type integer. This wait method will wait at most ms milliseconds plus ns nanoseconds and continue if notification does not come before this time. You can check here the method wait throws interpret exception in all the three cases. Here the thread main is going to sleep for 100 milliseconds. And of course, before the thread main calls the method wait, the new thread will notify the thread main before the thread main calls the method wait. But with the argument of the method wait, here we are passing the number 1000. That means the thread main will wait for the new thread for at most 1000 milliseconds, means for at most 1 second. If within the 1 second the thread new does not notify the thread main will continue its execution without getting any notification from the new thread. After 1 second, after 1000 milliseconds, the thread main will not wait for the thread new. Let's try this code practically. Open create thread.java and here with wait just write here 1000, nothing else. This is the only difference. Now try to compile these three codes once again. Compiles fine. Now run it. Java create thread. It runs fine and even if the thread main does not get the notification from the thread new, then also the thread main waited for the thread new for at most 1 second. So this is the new state diagram of the thread lifecycle. While running, a thread may call the wait method, then it will go to the waiting state. So either the notification comes or waiting time expires means argument to the wait method, that much time over, or waiting thread interrupted. If these three cases occurs, then a thread in the waiting state will go and get the lock again. It will remain in the waiting state but try to get the lock again. When the waiting thread successfully get the lock, it goes to the ready to run state, that is runnable state, and from the runnable state it will be scheduled by the scheduler.